Welcome Pure Maths 1 students to week 6 edition of our maintenance for the year. In our maintenance today we're going to be looking at quadratics, functions, and also for the first time we'll be doing some maintenance on coordinate geometry and a very easy question on differentiation. Let's get into it. We've got to solve the simultaneous equation. So what I'm going to do with this one, let me see, I will take this first one and make it in terms of x, so 6 minus 4y, and then I'm going to replace the x's in the second one with that. That's just the way I'm going to approach it this time. So that x squared becomes 6 minus 4y all squared plus 2, and then x is 6 minus 4y, and then into y equals 8. Let's expand these brackets, so we get 36 minus, what does that end up being? So negative 24, negative 48y, I think. And then last is positive 16y squared. Now if we expand the bracket now, I'm going to try and do it. So it's going to be 2 times 6, and then it's times by that y, so that'll be 12y. And then we'll have 2 times minus 4y, which is negative 8y, and then we times it by y, which is negative 8y squared. And then I'll bring the 8 from the right hand side across, so I have this, and I can now gather all my like terms in the quadratic. So I've got the 16y squared, these ones. So that will give me 8y squared. And then in terms of my y's, I got these, which gives me negative 36y. And then leftovers are 36 minus 8, so positive 28y equals 0. Okay, I think we can divide everything by 4s. So we get 2y squared minus 4 9s are 36, so 9y plus 7 is equal to 0. And at this point I think we can factorize. So 2y, So we have a y here. I think we have a minus 7 here and a minus 1 here. And that leads us to y being equal to 7 over 2 or 1. Okay, and then x. Therefore, x equals, and we just chuck it into this formula up here. So 6 take away 4 lots of 7 over 2. 6 take it. Now 4 lots of 7 over 2 is like 7 to 28 over 2, which is 14. So we're going 6 take away 14, which is negative 8. Or we could go 6 take away 4, which is 2. So the coordinate pairs 7, and which is minus 8 is the x value. 2, 1. Okay, well that was fairly basic in the end. Okay, now solving the following inequality. Let's see, I think we can factorize this. So yes we can. X plus 7, x minus 1, where is that greater than 0? Now the way to determine this is to find the roots. We know that we've got a root at minus 7. That's the first bracket tells us that. And we know that we've got a root at 1. The second bracket tells us that. And so, and since it's a positive quadratic, it looks like this. And we want to know, where is it greater than 0? Right, greater than 0. So you can see it's greater than 0 on the left-hand side of the minus 7 and on the right-hand side of the 1. So all we need to do is write x is less than minus 7, or x is greater than 1. And that one is that. Sorted. Okay, moving on. We're doing functions. we have two functions here, and labeled f and g. We've got to find the range of f. Now, this is a quadratic, right? F. So when you want to find the range of a quadratic, I suggest, well, you just want to use completing the square. So I'm going to rewrite it as minus 2x squared plus 4x, and then I'm going to complete the square by taking my minus 2 out, using my square brackets. Oh, it's now 2, isn't it? And actually it should be negative 2 to get that positive when we expand the bracket. So it should be that. And now I can complete the square inside that square bracket. And then I've got to take a 1 off. So I'm completing the square here. Remember what you do. You have the coefficient here, and then you square this number here and subtract it there. And what you should have, if you expand this, is the same thing there. Okay? Alright, now let's multiply out everything. I'm going to go over here for that. So I get negative 2 bracket x minus 1 all squared plus 2. And that means that the range, you can see that we've got a minimum point at 1, 2, right? Remember, you make this bracket equal to 0. That gives you the x value of the minimum point. Oh, wait, sorry. This is a max point. Why is it a max point? Well, because this is a negative quadratic. So it looks like that. So it's a max point of 1, 2. This is the value of y when x is 1, because 1 take away 1 is 0, 0 squared is 0, 0 times minus 2 is minus 2, and that becomes your y value. Okay, so we've got a maximum value of 2, which means we can say that fx is less than or equal to 2. Okay, next one. Find the value of the constant for which the equation gfx, so composite function made up of f into g and is equal to k, has equal roots. Now if it has equal roots, therefore the discriminant, which we learned about, must have a value of 0. Okay? Because remember, the discriminant is part of your formula of minus b plus or minus the square root of b squared minus 4ac all over 2a. And to get just one value from this instead of 2, this value here has to be 0, because square root of 0 is 0, and then when you try and add it or subtract it, you get the same thing. But if b squared minus 4ac is a positive number, you see that adding the square root of a positive number is different to subtracting the square root of a positive number, and you'll get more than one root, or more than one answer. Okay, so just that's a bit of a refresher there. Okay, let's make up our composite function. So we're doing g and we're putting f into it. Now remember, f is this, right? And we are putting that equal to k. Now put this into g. Now g, so this here becomes the x for g. Remember how functions work? So it's going to be 5 into minus 2x squared plus 4x plus 3 equals k. Let's expand it out. We get negative 10x squared plus 20x plus 3 is equal to k. Now I'm going to bring everything across to the left hand side. So I get negative 10x squared plus 20x plus 3 minus k. And now we're going to use this and use b squared minus 4ac. So this is a, this is b, and this is c. So let's do that. we want to make it equal to 0. So let's do b squared, so 20 squared, get some space here, 20 squared minus 4 times negative 10 times, and then we want 3 minus k, so we're going to bracket that. We get 400 plus 40 into 3 minus k, should be equal to 0, remember? And that gives us 400 plus 120 minus 40k equals 0. So we get 520, and then I can bring that 40k across the right side by adding. And then I'm going to divide both sides by 40, and so I get k is equal to 13. Okay, so that's our functions for today. It reminds me of last week's one. I wonder if it was the same. Okay, so for this next one we're doing some coordinate geometry. We've got this triangle here. We've got coordinate A, coordinate B, and we know that the gradient of AB, AC, and BC are 2m. Okay, so this is gradients. 2m, AB, minus 2m, that's AC, and m is BC, respectively, where m is positive and a constant. Okay, find the gradient of AB and deduce the value of m. Okay, fine. So gradient is delta y, change in y, change in x. Okay, so, and we know it is equal to, in this case, we look at our y values, we've got a 22 here, and a minus 2 here. So I'm going to go 22 minus 2 all over. Then we use our x value, so 15 minus 3. So we get 24 over 18. Wait. No, 12. You're Larry. Okay. 2. There we go. Okay. Now, that is equal to 2m. Why? Because the gradient of AB is also 2m. So therefore we can say that m is equal to 1. M is equal to 1. Okay, perfect. Find the coordinates of C. Okay. Okay. So what we're going to do, we know the gradients of, okay, yeah. So we need to find, we need to find an equation for this line here, and then we need to find an equation for this line here, and find out where they meet. Okay, that's what we're going to do. So since I've got the green on now, I might as well start with that. Okay, now what do we know about AC? Well, we do know that AC has a gradient of 2m. Now, the formula that we use here is y minus y1 equals m, the gradient, into x minus x1. Now, so y, what's the y value on this line? So we're looking at this bit here, we're using a, y minus 2 equals, now what's the gradient of AC? Well, they told us that the gradient of AC is minus 2m, so m is 1, so it's just going to be minus 2. X minus, oh, it's getting a bit crowded up there, what is that? It's a 3, isn't it? Minus 3. And so we get y plus 2 equals negative 2x plus 6. We simplify that and we get y equals negative 2x plus 4. So that's that one done. Now let's take a look at BC. So BC, y minus, now what's, we're going to take these coordinates, y minus 22 equals m. Now what's m for BC? BC, m is, it's just m. So is it equal to 1 into x minus x1, which is 15. Y minus 22 equals x minus 15. Oh, I could have done that in one step, but anyway. Y is equal to x, minus 15 plus 22, so that's x plus 7. And now we have to determine where does this line meet with this line, and all we do for that is we make them equal to each other. Whoops, it's a bit thick, isn't it? X plus 7 equals negative 2x plus 4, and so I could get the negative 2x across to the left by adding 2x, and then I could get the 7 across to the right by subtracting 7, which will give me a negative 3, so I think x is equal to negative 1, and that's where it where the x value for c is, right? So this is negative 1, and now we need to find the y value. Therefore, y equals, and we can just chuck it into either of the equations, but I'm going to chuck it into this one for hopefully obvious reasons. Y will be minus 1 plus 7, which is 6. So the coordinates of c are negative 1 for the x value, comma 6. So that wasn't so hard, was it? Okay, the perpendicular bisector of AB, okay, so we've got more here, meets BC at D. Okay. So what do we need from this? We need the perpendicular bisector. Okay, now, a perpendicular bisector, we know two things about it. If it is a perpendicular bisector of AB, we know that it crosses halfway, so we're going to need to find the midpoint. Okay, need to find the midpoint. And we need to find the negative reciprocal gradient, because it's perpendicular. Now, that means, let's do the midpoint of AB to start off with. So I look at my coordinates there, and I'm going to add my x values together. So it'll be 15 plus 3 over 2. And then my y values together, which I think was 22 and negative 2. Okay, and the coordinates will be 9, comma 10. The gradient is a negative reciprocal. Now let's have a look. The gradient of AB is 2m, right? We're told that here. So the gradient of the perpendicular will be negative 1/2. So you take that 2, flip it, and stick a negative in front of it. So let's find the equation of the perpendicular bisector. We use y minus y1, so y minus y1, which is that 10 that we found just earlier, equals m, which is our negative half gradient, into x minus x1, which is the 9 that we just found. Then we're going to just expand that out, so we get negative 1/2 x plus 9 over 2. We'll bring that 10 across, and we'll get that's like 29 over 2, isn't it? Negative 1/2 x plus 29 over 2. I've just converted that minus, well, the 10 when it becomes a 10 when it comes across, so it's like 20 over 2. Okay, so that is our equation. Now we want to know, where does it meet BC? Now BC is the pink equation. This one here, isn't it? That's BC. Y equals, so pop that down here. Oh, that didn't even work. Look, I'll just rewrite it. Okay, so this is BC. So we want to find out where this meets that. Okay, so let's go ahead and try that. Okay. So we go x plus 7 equals minus 1/2 x plus 29 over 2. And then we bring everything across, so we get 3 over 2x equals, and then I'm going to take away so the 7, which is like 14 over 2, from 29 over 2, which gives us 15 over 2. And then I could just times everything. Whoops, what am I doing? You can see there that x is just going to be equal to 5, isn't it? And therefore, y is equal to, I can chuck it into this one, that's easiest, 12. So the coordinates are 5, 12. Okay. Alright, so for the differentiation question, this is nice and easy one to finish off. We've got to find the gradient function for 5x squared minus x plus 1. So dy dx is equal to, now what do? We take this number here, we multiply it by the 5, so we get 10x. We drop the power down to 1, and minus, we do the same with x. Now that's actually to the power of 1, isn't it? So it's just, we times the x by minus 1, and we drop the power down to by 1, and these just drop out. Now obviously I can express that another way. I'm just going back to refresh your memories. That's just 10x minus, now x to the power of 1 is 1, so I can just write it like that, and that would be it. Well, please send your questions to me. If you've got any trouble, let me know. Happy to help. Add a comment in, or a ThinkWave message to me if you're really stuck with any of these and I haven't explained it well enough. Alright team, God bless. See ya.